Alright everybody, welcome to lesson 2. We're going to start talking about dividing fractions by whole numbers. And dividing usually causes a little bit more of an issue for people, especially when it comes to the models. They're kind of tricky. So just take a watch, and any other questions that I don't know and you want to try them, just check the solutions. They'll be in the links underneath. Okay, so just a quick recall of what division means again. Okay, so in the equation 6 divided by 2 is equal to 3. The dividend is 6, the divisor is 2, the quotient is 3. Okay, so just got to remember those words. And this really means that if you have 6 things and you divide them by 2, you're making the answer represent the number of groups that you have. Okay, so this means that if 6 is separated into 2 equal groups, there are 3 in each group. Okay, the answer you end with is how much is actually in a group. So for that first example, let's think about dividing using a model. Okay, so I have 1/4, okay, a quarter of a whole piece, and I want to divide that by 3. Okay, I want to divide that by 3. In other words, I want to take 1/4 and split it into 3 equal groups. And I want to know how big each group actually is. So I'm going to draw you a little fraction strip here, just a rectangle. Okay, easier to think about this. And let's split this rectangle up so we can show exactly what 1/4 is represented by. So if I cut it in half first, and then cut each of those halves in half, and I know it might not be totally to scale, just based on how terrible my drawing is, but as long as it looks like it's 4 parts, that will do for us. Okay, so there's my bar cut into 4 pieces. Now each of those 4 pieces is what we want to cut into a third. Okay, so I really am only talking and concerned with 1 out of those 4 parts. Right, that represents my 1/4. Now if I were to take that 1/4 and split it now into 3 equal pieces, and you imagine cutting the rest of the bar into those same pieces, right, because everything is getting divided by 3 here. I cut into 3. Now the entire bar has 12 parts. However, we are only concerned with now 3 out of those 12 parts. So my 1/4 that I originally started with is the same thing as saying 3 out of 12, because all of those other additional pieces are each 1 out of those 12. And if I had all of them added together, I would have a full fraction strip, right? 12 out of 12, in other words, 1 whole. Okay, now all of the 3 that I have combined make 3 out of 12. Division again is concerned with how large each group actually is. So since I've taken 1/4 and cut it, divided really, by 3, each of those parts that are in that 1/4 section, okay, and you can see it's overlapped, right, they're both colored, okay, each one is only 1/12 of the full piece. Okay, so each of the 3 equal parts is 1/12. So that means for us, if I take that 1/4 and divide by 3, I'm going to have pieces that are 1/12 in size. Okay, the answer when you divide is how big a group actually is. I have 3 equal groups of 1/12. That represents my 1/4. So the picture's a little tricky. Okay, division is a little bit more tricky to work with than multiplication. So we can show this one other way by using a number line. Okay, and it's very, very similar as using, a fraction strip. But if I try to take 2/3 and again divide by 4, right? So here let's take a number line. Okay, and we'll start at 0 and we'll end at 1. So if I had every piece on that number line would represent 1 whole. So I'm going to divide it into thirds because my fraction is in thirds. So here's 1/3, and over on the right side there, that would be 2/3. Okay, just roughly showing a third per piece. Now to model that division by 4, we're going to take each of those 1/3 pieces and we're going to divide them, we're going to cut them into 4 equal parts. Okay, cut them into 4 equal parts. So easiest way is to go in half and then half again, and you can count 1, 2, 3, 4, make sure we got all the pieces, which we do. Okay, so in half and then half again, in half and then half again. So now again, that entire number line, if I had all of it, I would have 12 of the sections, right? 12 out of 12 again would be one whole. There's 12 parts in that whole number line. However, we don't have the whole number line. We only have 2/3 of it, right? Oh, I went too far. Okay, so we only have 2/3 of that number line. I don't have the whole thing. Okay, so now what you can think about is if I have those 2/3, right, think about how many pieces there would be in each group if I took the 2/3 that I have and cut it into 4 equal parts, okay, because we are trying to divide into 4, or divide by 4, I should say. Okay, so let's just try to count this out. 1, 2, 3, 4. Okay, so there's a group of 4. And, oh, sorry, 4 equal parts. My mistake. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 pieces altogether. So 4 equal parts would mean for us that there are 2 in each group. Okay, 4 equal groups of 2. Okay, so each of those parts of 4 contain 2 out of the 12 total sections. 2 out of 12. Okay, so 2 out of 12 is how big each group is going to be, and if I reduce that, it ends up being 1/6. Okay, so if I write the full statement, if we start right from the beginning, 2/3 divided by 4 is going to equal 2/12, which reduces to 1/6. Okay, the 1/6 shows how many are in each equal group. Now there is a pattern that maybe some of you have picked up on. If you take a look at what ends up being the whole number and your denominator, right? So my denominator is 3, the whole number is 4. Think about what happens when you multiply 3 and 4 together, right? If you multiply 3 and 4, you end up with 12. Interesting. If I do 3 multiplied by 4 again, I get 12. Look at that 2 that's in the numerator there. That's the same 2 I had in the beginning. That's the exact same pattern that works out in example 1. So 4 multiplies by 3 to give us 12. And the 1 I had in the numerator is the same one I have in the numerator in the end. So there is a nice pattern here that works. Okay, what do we notice? The whole number multiplied by the denominator gives us the new denominator. Okay, and the numerator stays the same. So that's super helpful. So if I try to use that to help with the third one, well, let's try to use that pattern. If I take that whole number, 5, and I multiply by the denominator of 2, I get my new denominator, 10. Numerator stays the same. Works out perfectly, right? 1/2 cut into 5 parts. Each piece has the size of 1/10. Okay, it's very, very helpful to remember those two things. Okay, very, very nice. Okay, so you can pause it, you can try out those two for yourself. I'll have the answers again in the solution so you can take a look. If we try a little bit of an application, okay, Mustafa uses 3/4 of a jar of pasta on 6 servings of pasta. Oh, sorry, pasta sauce on 6 servings of pasta. He used the same amount of sauce on each serving. What fraction of the jar of pasta sauce did he use on each serving? Well, if I used 3/4 of a jar of pasta sauce for 6 servings, and each serving gets the same amount, really what we're asked to think about is taking that 3/4 and splitting it 6 equal ways. Okay, so however you choose to represent that, totally fine. I'm going to use the rule we just talked about in the sense that I can take my whole number, which is the 6, my denominator, which is the 4, and those can be multiplied together for our new denominator of 24. The 3, which is my numerator in the beginning, stays as the numerator after you divide. Okay, so 3 out of 24 is what I'm going to end up with, and we can reduce that further. Okay. Both of those numbers are multiples of 3, so if I divide both the numerator and denominator by 3, okay, we're going to end up finding out that it's 1/8. Okay, 1/8. So Mustafa used 1/8. It's not a very good 8. Oops. 1/8 of a jar of sauce per serving. Okay, and there we go. Okay, multiple ways to use and represent division. Key ideas: you can show it using a model and a diagram. Now, the second bullet there just restates the division algorithm. So dividend, divide, divisor equals quotient. Okay, quotient is the word for the answer of division. Okay, you got a couple questions here which you can try. So divide using the method of your choice. Maybe try a mix of the two, and I'll have the answers for you in the link down below. And there's a couple word problems that you can try also. Okay, so highly advised, just try them out. They don't take too long. And you can check to see how you did. When you come back for the next one, we're going to start multiplying proper fractions. So what happens if both parts of that multiplication statement are fractions? Okay, that's what we'll talk about in the next one. So again, I hope it helps. You'll find the link for the next video popping up right away here. Take care. We'll see you next time.